Okay, suppose a vector is 10 units long and it makes an angle of 120 degrees with a positive x-axis. That could be 10 miles or 10 whatever. Could we write it in IJ form? And that raises a very interesting question if you want to see a picture of it. This is it. There's our vector 10 units long making an angle of 120 degrees with a positive x-axis, which is running over this way. But now how could we write this vector in component form? And first of all, I want you to think about something. How could we represent a unit vector that's in that direction? Okay, pause for a second. Now, resuming from that pause, I hope you came up with the idea that if we just use the vector cosine of 120 degrees times I plus sine of 120 degrees times j, that would give us our x and y components of a unit vector in this direction. Now all we've got to do is multiply that by 10. So, manipulation-wise, it's 10 times cosine of 120 degrees times I plus sine of 120 degrees times j. All right, that's not a good answer for a question. It's a correct answer, but I would rather just do strictly in IJ form without these trig functions thrown in there. So then we have to think about what is the cosine of 120 degrees. Okay, so cosine of 120 degrees. First of all, it's in the second quadrant where cosine is negative. Second of all, the reference angle is a 60-degree reference angle. It's this one, right? And so this would be negative cosine of 60 degrees. So this is going to be 10 times negative the cosine of 60 degrees. First of all, cosine of 60 degrees is square root of 3 over 2. But it will be a negative number, so negative of square root of 3 divided by 2 times I. And then plus, okay, now what about, boy, that doesn't look like negative there very well, I'm sorry to say. Let me mess with my software and make that look a little better. There, haha, much nicer now. Because that almost looked like it was part of the radical sign. I didn't mean to do that. Sine of 120 degrees. Now sine in the second quadrant is positive, and it's the y value here. And of course, sine of 120 degrees would be corresponding to the sine of 60. And boy, I hope you guys weren't going to let me get away with this incorrect answer here. This is the one that should be negative 1/2. Duh. And this should be positive square root of 3 over 2. So square root of 3 divided by 2, j. And there is our correct answer. Do you understand why that's negative 1/2? Because cosine of 60 degrees is positive 1/2. So cosine of 120 is negative 1/2, same reference angle, but quadrant 2 where x values are negative. And sine of 120 is exactly the same as the sine of 60, which is the square root of 3 over 2. So really a better answer than this, though, you have to admit. It would be a lot prettier if I just wrote it negative 5i and then plus 5 square roots of 3 j. A much more satisfactory answer is this one.